Thank you for attending this month's MESTUG United event. It's November. This year's going past really, really quickly. So you guys, thank you for attending. This is normally the crazy part of the year. So this is the second last event for the year. So what we're going to do is our normal community intros, just to start this event. We have one more event left, as I mentioned, the December event, which is going to be very similar to tonight's event. Tonight's event's about .NET. The December event is about Microsoft Ignite, and we're going to have some cool content about Teams and using Microsoft Teams together with the Power Platform. So I hope to see you again. Just remember, it's not in a full month's time. It's very soon. The next event will be on December the 8th. So it's actually very, very soon. So I hope to see everyone there. This stream, as you know, the format has changed. We now streaming to both YouTube and Twitch. If you have any questions, please feel free to drop your messages and your questions or anything that you want to say, hopefully good things, into the chat in whatever platform you're using. So in other words, YouTube chat or Twitch chat. And we will try and answer any of the questions to the best of our abilities. If we don't know the answers, we will definitely find out for you.
The original prototype of ASP.NET I wrote over Christmas, New Year's between 97 and 98.
We knew we had to create something that broke a lot of new ground.
You can see a lot changed.
It's been an incredible journey to get where we are today.
It started in the community. This is an experience.
I'm seeing we have people from all over joining us.
Every developer can actually develop any application super productively for any platform.
Pretty cool.
It's almost like science fiction how far it's come.
This is only the start.
The Academy of Motion Pictures Arts and Science. They are using .NET to deliver a multi-device streaming service to their Academy members.
Get started writing your cross-platform mobile apps.
.NET is open source and it runs everywhere.
You're at this powerful cockpit of all the things from production, editing, hot reload.
We're here to serve. What we want is to make developers happy.
Woo! Simple as that.
I would say get involved.
Come to us with your feedback.
Congrats on another amazing .NET Conf.
Yes, so why we're here today, we're going to have our own South African .NET Conf event. For those that didn't attend the .NET Conf event, it was the biggest .NET event of the year, and exciting things happened at the .NET Conf event. Things like .NET 6 was released and things. So what we're going to have is a celebration of that event and have a uniquely South African version of it, and we're going to celebrate the fact that, and it's very exciting to say things like this, that .NET can truly run everywhere. So we're going to focus on all the different places where you can use your .NET skills, and we're going to cover things like Blazor, we're going to cover MAUI, we're going to have some demos on IoT, we're going to look at the Nano framework, we're going to run some .NET 6 code on Raspberry Pis and things. We're going to pick some interesting things that we find interesting, hopefully you find interesting as well. Yeah, that's .NET Conf event was the 9th of November. It was a 3-day event. That content is still available. It's all on YouTube as well. If you go to that website, you'll find all the links that you need to get to that cool content. Right, so .NET is a unified development platform for all these environments. So what's happened with .NET? It's now a unified runtime, a unified compiler, and of course, languages to support that. There's a BCL or common base library that is common across .NET 6, which allows your code to be shared across many devices, many environments. You can run .NET 6 quite happily in the cloud on Azure or AWS or any of your cloud platforms. You could create server-side implementations with .NET using ASP.NET. It could be local web servers, it could be on-premise web servers, cloud servers. You could have a server implementation of Blazor. You could have client-side Blazor running .NET in your browser. You could create desktop applications with something like .NET MAUI or older frameworks like WPF. I know there's loads of developers out there that's running WinForms apps. Everyone's got a WinForms app somewhere in the closet that they need to support. You could do that with .NET 6 as well. Mobile, everyone's favorite Xamarin falls under mobile with the new .NET MAUI coming out. It's available in preview, so you could do mobile development too. You could do gaming with tooling like Unity. There's other gaming libraries also using C#.NET as well. You could do IoT development, which is on ARM devices like ARM32 or ARM64. You could do AI with something like ML.NET for machine learning using your .NET skills. You could use .NET in Apache Spark, and all this goodness of .NET is underpinned by a rich ecosystem. You can get libraries and components via NuGet. You have tools like Visual Studio on Windows to build your solutions out. If you a Mac person or Apple person, there's Visual Studio for the Mac as well. There's open source Visual Studio Code, which is also multi-platform, which runs pretty much everywhere. It even runs in a browser. So whichever tool you want to use, there's an environment for you to work. If you don't like tooling, there's a command line interface as well, so CLI. So if you want to use Notepad to code with, knock yourself out. A big focus on .NET 6 is performance. So there's been huge amount of work in making .NET faster. It was already very performance already in .NET 5 and before that as well, but they've improved it even more. So it's 10 times faster with ASP.NET Core and Node.js. Something else that's interesting between it's not just web performance, it's actually the entire .NET stack, and of course components that go with it, like Entity Framework Core. Just an interesting fact that .NET 6 is 92% faster than .NET 5 for Entity Framework Core. So all these good things come together in making your code run as efficiently as possible, which means nice things to you, like if you're running in the cloud, you're using less compute, it becomes cheaper. If you're running on mobile devices, with your code being more efficient and more performant, you have also nicer spin-offs that maybe less battery usage on an Android device or an iOS device as well. And it also starts allowing it to be able to run on constrained devices like your IoT devices and lower power, lower memory devices as well. So this .NET 6 performance improvements are really important for the ecosystem. So yes, .NET 6 was released at .NET Conf. As mentioned, is a unified common base library and SDKs. We've touched on the performance improvements. There's simplification in development as well. It's easier to get started. There's also tools to help your developer loop be more efficient as well. There's new features in C#. There's a new version of C#, which is C# 10. There's also a new F# as well, F# 6. There's been improvements made as well for Apple Silicon. So if you're an Apple M1 user, there's ARM64 support for .NET 6 as well. And what's really nice about this release, it's a LTS or long-term support release, which then means you have confidence that whatever you build on .NET 6 will be supported into the future. The day before, .NET 6 was released. Visual Studio 2022 was released. It is the first Visual Studio, which is quite a major milestone. It's the first Visual Studio that is 64-bit, which allows us to now actually harness the full power of our 64-bit machines, and we can load large code bases, and we could get efficiencies out of that from just purely being 64-bit architecture. There's support built in tooling for .NET 6, something that I really, really love, and we're going to cover that through the evening as well, is hot reload. It's hot reload everywhere, which greatly improves your team productivity. There's also part of that is web live previews. There's AI-powered IntelliCode, and the general debugging and testing tools have been enhanced as well. But we'll cover some of those aspects as we go through the evening, and we will be demoing some code as well within Visual Studio. There's an .NET updates or upgrade assistant. As mentioned, there's people with code bases and legacy code bases that need assistance to move to the latest versions of .NET. So what the upgrade assistant is there to do is to make your life easier and reduce the time and make it easier to move and modernize your old .NET code bases. It's really nice to use. It's guided step-by-step experience. It supports multiple project types because most solutions have many projects of different types. It supports C# and VB. Everybody has VB somewhere in the environments, a VB in the closet. And of course, the upgrade assistant definitely supports .NET 6. So do look at that if you want to migrate your projects to the latest version. So hot reload is I can't live without hot reload anymore. It's one of these things that once you've had it, you can never go back. It speeds up your development. So nobody likes, especially building like a UI-based system, that you've got this screen flow of like maybe 10 screens. You have to jump through like a login screen to get to screen 10 and have to navigate for that. What hot reload does is it allows you to change your code in place. So while the app's running, you can change the code and it gets applied immediately. So no more restarting and going through that workflow of login screens and multiple screens to get to where you need to be, or in a non-UI application, you might still have to get to some sort of state. You can edit that state at that moment in time. So there's less restarting. So of course you save a lot of time. So your developer loop is improved radically. It's available in the command line. So the command line with the .NET Watch is supported, and it's also supported in Visual Studio 2022. It supports all project types. It even supports .NET versions, the full or the original framework 4.6+. Of course, it will be best with always with .NET 6 in your environment. Okay, over to Matthew.
Just making sure I'm unmuted. I was just about to start speaking and I thought to myself, just check. Yes. All right. No, thanks, Allan. Because it's really cool stuff coming with .NET 6 and the IDE and the tooling and sort of the whole story with the new .NET 6 is how can we make developers' lives easier? And not only are we doing hot reload and making the developer experience easier in the tools, we've also tried to make it better in the code. Like can we reduce the code? Can we clean up the code? Can we reduce boilerplate that you had to have in every single file, for example? And some of those examples are like it can be seen over here on the slide. It's like in almost every single C# file, you're probably importing, system, maybe system collections, generic collections, or maybe link. And at the end of the day, you end up with a massive chunk of usings at the top that just in all the files is like, why can't we move that somewhere else? Like, just always import these. And obviously with C#10, we now have a new feature, global usings, that we can you stick that in a file or at the top of a file, and all the files in your project will suddenly get this implicitly. And that's really cool for especially large projects with many namespaces. So that's really cool. And also one thing is like, okay, so every file has a namespace, and that means every file has an indent, either 4 spaces, or if you're crazy, an 8 space. And if you cool, use tabs, however you want to do it, but it still has to be visually white space indented. And of course, with a new thing, with a file scope namespace at the top of the file, you just say, hey, this is namespace, and you stick a semicolon, and then all of a sudden you have one indent less. So that's really cool. It cleans up the file quite a bit, and you'll see from our code when we're demoing today. So that's pretty cool. And some cool new features that allow, again, for more cleanup. So let's say you have a struct or a class that you want to define, and you have to do a constructor. You have to have properties with getters and setters. Maybe you want to do some, constructor overloads, and then you want to do check for equality and get the hash code and all that stuff. It's like, oh, you have to do it for everything. And it's just like, why can't we do it magically? And that's where the brilliance of records come in. So if you stick public record struct or public record class, and the definition becomes the constructor as well as the list of properties to define, and some really cool stuff. And I just remembered I don't have any of that in my demos, and maybe if there's time we can quickly modify a file. We can see how cool this is. And some other cool things for those who work with a lot of functions. Instead of having to use func and action all over the place with lots of generic arguments, that eventually you end up with 4 or 5 of them, and you don't understand which int is with which parameter, you can now sort of use the var keyword for if you're into that, to basically implicitly define the type, and it basically reduces your code again and removes boilerplates. So that's really cool. It's just cleaning up the code and improving your life. All right. And on that sort of train of thought of cleaning up the code, let's say you're making a web app. You spin up the web server, you have a couple of files, and you have a few API controllers and a few path registrations and the attributes all over the place and trying to get the thing going. Well, what happens if you don't want to do any of that, but you still want to make a web API? And that's where the ASP.NET team has been working really hard to say, hey, how can we reduce all of this? Like, of course, you want to have a get method. So why have a class? Why do you need attributes? Can we not just define this as like, I don't know, a simple one-liner? And if you look at the code on the screen, that is a very simple web API that you can use. It's no need for controllers and classes and MVC structures and attributes. It's just one line on the screen. And if you hit that, the root, you get that, and you can put whatever there. You can call any methods. You can use your services. So it's really, really cool to get started, to clean up your files, especially for smaller web APIs. And this is one thing that you might do for if you're doing microservices. The whole point is to be small, and yet a whole bunch of ceremony. So it's really cool to go check that out if you're doing web APIs. Less stuff in the file is easier to maintain. There's less code, there's less bugs, code to be buggy. Another cool thing that's sort of on the train of announcements. If we flip the switch a bit there to talk about what's new, and we're talking about web right now, there's a whole bunch of new .NET 6 support everywhere. So we all know it runs on mobile and IoT and Azure. Well, that's cool, but where on Azure? Well, it runs everywhere on Azure. So if you're doing app services for hosting web apps or APIs or mobile backends all across the world in all the regions for both Windows and Linux, you can get started using .NET 6 today. And some cool new things if you're doing web apps, static web apps, using like Azure Functions or like Blazor WebAssembly with AOT. That's all of that, again, all powered with .NET 6. You can upgrade your your functions runtime to 4.0, and it just works across the board. So if you're using Azure today, just flip over to .NET 6 and maybe it'll be a seamless upgrade and massive performance increase. Can't promise that, but there are numbers showing that it's true. So at some point, your apps will run faster with less effort. Okay, all right. So Blazor. No, this is one of the paradigms of creating web apps that .NET supports. There's so many of them, and one of them is Blazor. And with Blazor, for those who don't know, it's basically built on top of ASP.NET. It's a system to present HTML in your web browser to various people across the world, whether it's in the mobile browser or the desktop browser. And there are two ways this can happen. You either have like a server that sits there in the traditional form, it does all the work, and it just sends HTML and messages across to the client. Or there's the opposite way that's new to .NET. It's like, hey, wait a minute. Let's just ship the entire thing over to the customer's browser. So with a web server, if you click a link, for example, it will download the HTML for the page and display it on the screen. Whereas in the WebAssembly model, it's like, wait, if the browser is the server, you click a link, let the browser do the processing, generate the page, and present the page. And it's really cool advantages you can get with either way. So, if you need access to direct links to SQL Server databases for whatever reason, maybe you want to have some faster startup, or you've got some production code or proprietary code you don't want to leave the server, or you need to support a browser that's like running on a device that has nothing, that's where you would have everything on the server and the client just asks the server for things. And if you say, hey, wait a minute, I want to use a modern browser, I just want to ship it all over to the customer, and I want to, not need a server running, that's great. We can try WebAssembly. Check it out. It's the same code, runs everywhere. It's the same components, and it's pretty cool to check out that. And what's new with .NET 6 is we've taken Blazor WebAssembly and said, hey, wait a minute, can we improve performance? Yes, we can. So we now have AOT support. So you compile down directly from your IL to WebAssembly. The app sizes are getting smaller. And we've got some cool new features such as error boundaries, which I like to think of it as like a try-catch block for Razor. So if there's an error in your rendering code, it doesn't crash the app, which is really great. And a whole bunch of new features such as component type inference or generic type. So basically Razor now supports generics, really cool, and dynamic components and sort of persistence when you're doing pre-rendering. So instead of rendering an empty page on the server, sending that to the client and then wait for a whole bunch of web requests to load the content, you can sort of preload it all. So it's all sorts of cool things you can do, and stacks of improvements across the board. You can check out the blog posts on the dev blogs to Microsoft.com. So it's really cool new things coming and just making lives easier across the board. And in the train of Blazor, Microsoft has Fluent UI. It's a sort of a design paradigm of way things look, and you can see from the picture that it's sort of clean, it's keeping it light, keeping it friendly, and this is supported on many different technologies, Angular and all that sort of things. But Blazor sort of takes that and says, how can we make life even better? So instead of worrying about CSS styles and calling JavaScript functions, you can set properties and use the sort of the dynamic nature of Blazor and Razor to basically render it and use item templates for lists and things instead of having to loop through items and generate HTML. So it's taken what you know and love about Fluent UI and making it better. And not only is it better, it's more accessible. Microsoft's definitely focused on making things more accessible to all different types of people, whether it be disabilities or alternate abilities, shall we say. It's making sure you get your, like, I like my dark mode, I like my light mode. Hey, I can't read too tiny text, I need it bigger. All these type of things, it's all available. So definitely really cool. And not only is it awesome, your life is easier, it's got so many cool features, it runs better than ever, but it runs everywhere because it's a web technology, and Office and Teams and all the rest of the various tool suites, they have support for web extensions. So you can have an Outlook plugin that's using Fluent and Blazor, and it's just it just works everywhere. .NET is incredibly cool. I love it. Okay. And finally, one of my favorite topics about .NET is .NET MAUI. For those of you who know Xamarin Forms, it's the sort of Xamarin Forms 2.0, but since we had Xamarin Forms 5, it's sort of Xamarin Forms 6.0. We've gone ahead and said, hey, we've been doing Xamarin Forms for many years. How can we learn from what we've done? How can we make lives better? How can we take modern development practices and bring it right into there? So we've gone ahead from the bottom up and say, how can we improve it? We're still keeping that native cross-platform UI. The Android button is a physical Android button. UI buttons on iOS. Windows, we've started integrating the Windows App SDK and bringing in WinUI, so we're using their buttons. And right now in Preview 10, you can't see the beauty of the Windows 11 buttons, but in Preview 11, that's coming out real soon. The buttons, the text boxes, they look like they fit on your operating system because we've gone ahead and said, all right, let's use the native styles, and it just magically looks awesome. So really cool stuff. And another cool thing that we've been working really hard since, I don't know, as far as I can remember with Xamarin, we've been trying to, get rid of projects. So I want to have an app, a Xamarin Forms app or a MAUI app, and I only want one project. Why should I have an Android, an iOS, a Mac, a Windows, plus a shared project? It's like, just stick it all together. And over the years, we've gone from file sharing to, everything's in the .NET Standard library. And finally, my dream has come true. .NET 6, it's a single CS project that has everything in it. And you can pick from the drop down in the run button in VS. And it's just, you want to run on Android? You run on Android. So it's really cool. And I'll be showing off some of that. And not only are we developing to Android and iOS, we can also be deployed to, Mac or Mac Catalyst and WinUI, Windows Desktop, and we'll see some of that today. And of course, all this goodness is coming out next year, but the previews are available today. So head over to .NET MAUI or download VS, get started making awesome apps. All right, let's hop into some code. Here we go. So thought I'd whip up an exciting demo app. Not much time to go to all the nitty-gritty details, but I'll be pushing this code up online soon. But I thought, hey, let's start off with some cool things, and I'm just going to show how .NET really just runs everywhere. So there are 5 projects to the solution. There is 3 at the top, 3 sort of library projects. These are the core part of the application. They are shareable. And then, of course, we've got 2 different app heads, whether it be a mobile app, like using Android, iOS, or Windows. And then there is a website that renders HTML using Blazor. And in this case, I'm using Blazor WebAssembly because that's radical. So with the core library, this is plain .NET 6. It doesn't have a dependency. It's just where I put my services, my interfaces for my services, maybe some models and cool things. And it's this one over here. We could check it out later. And then, of course, we've got 2 other sort of specific library projects. We've got core.mobile, and this targets Android, iOS, and Mac Catalyst, and also plain .NET 6, just in case we want to do something. And that takes advantage of using the MAUI, the single project that comes with MAUI. We've been working on with MAUI. It says, how can we have a single project that's targeting Android, iOS, and all the platforms together and use native API? So on iOS, I want to use, for example, in this particular example, I'm getting the GPS. So I want to use the location services that the operating system provides, and that's what I use in the core.mobile. And of course, in core.web, we've gone the opposite and said, hey, I want to have a .NET 6 library, and I want to render, Razor components. And this is what you would do in a normal Blazor app, but now we've got one over here. And the reason this is cool is because these can be used by the different app heads in different capacities. So in the case of mobile, we can obviously access the core.mobile, which has the device capabilities and get the GPS, as well as we can use the Razor web components that were traditionally that was part of Blazor, but now we can actually use Blazor inside a mobile app. And it's really cool because it's not like, oh, we've got a hosted, web view and we're shelling out to some server somewhere. No, the very same runtime that's running the app is also running the Blazor component. So it's really crazy. and you can share state across the board. And not only that, if we hop over to the Windows side, is we use those very same web components as well as the shared services. So in this case, we are sharing code across a mobile and web. And I'm sure when Allan's going to show some demos, it's going to be taking various .NET libraries and say, hey, how can I bring this to an IoT device? So you can technically, well, not technically, you can run a library, write a library that runs everywhere. If you target .NET 6, wherever .NET exists, you can run some .NET library code. So that's really, really cool. So I thought, hey, let's hop into some code. Let's head over to the core project and let's have a look at some code on the screens. Space on the side is reserved for some emulators, which we're going to see pop up soon. So in the .NET 6 library, I have a cool class over here, and I've gone ahead and used some new techniques, and I've said, hey, here's a namespace. It's namespace. You've got a semicolon. No need to have the indents as we all love. Pushing the wrong key there on my keyboard, like that. Like, hey, we don't like that. Let's just make it an inline. There's no namespaces. Oh no, where's the namespace? Well, this one doesn't really have any, but if we hop over to like this, the datetime offset, where's that system namespace? Well, we're now taking advantage of global usings, and it just magically does cool things. And we can also show off those cool new public record, and we can say, hey, we just delete that and that and that. Shift end. No, oh gosh, I clicked the wrong key. I got a new keyboard because I'm radical that way. Right before that demo, I get myself a new keyboard because the old one was, there we go, look at that. And let's just call this latitude, longitude, and city name. Look at that, amazing. There's no code, and the code that was using this should have no errors. I guess we'll find out. And look at that, no errors, because we did amazing work. So you sitting there at home thinking, oh no, lots of lines. It's like I had to put white space, new lines here just to make it more, just so it doesn't look too weird, because it's not. So this is really cool with the new things to C#, or showing off some stuff there. But in the case of this one, we've got some shared codes, hitting the web API, downloading some stuff, looping over some things. Here we've got a nested function that came with the .NET C#, some older version, I forget. I've been using it for years, really cool, you know. And obviously I've got my interfaces and my services. Then I go to my mobile one, I say, hey, I want to use the native APIs, and here we go. On Android, I'm spinning up the old, in this case, I'm using Essentials. Technically, this is already cross-platform, but I thought, hey, let me demonstrate custom code on different platforms. You know, I don't really want to hit the native APIs for this because it's quite complicated, so I'm cheating here.
You're just showing off.
You just assume that this is high-tech, lots of lines of code, all the various listeners that Android requires, and service permissions and stuff. But this uses native APIs under the hood. And yeah, we've got a normal view model. It just exists, you know, using dependency injection with the constructor arguments here. I mean, just give me the geolocation, and a whole bunch of cool things, all available with .NET MAUI. And of course, the last web one is just the normal Razor web component. Again, some dependency injection up there. We're rendering some Razor. All right. Phew. Try to rush through this so that we can show off the cool things too. So let's head over to the website first. So if I run this, let's hit F5, and the page that I'm going to be showing you is this weather page. This weather page has a web component. Whoops, I can't navigate the code as the IDE switches. And this Razor component is the one I showed you in the mobile, the web app project. This Razor, we just have a project reference to it. If we look at this cool new one, here's the web one, and in this case, we just reference it, right? And here we go. When I switch to the right browser and I switch to the thing, yeah, it's downloading some data. Yeah, it's getting my location. So this is all live right now. It's using mock data, and I'll show you some cool things. But here we've got a web component here that is written, that's doing some stuff, and all we had to do was import it. And this is cool because we can reuse it in our mobile app. So let's hop over to the mobile app. Stop this. And so just to reference, we've got one Razor library, Let's make this a startup project. Let's pick Windows. No, let's not pick Windows. Let's pick someone. Is my oh no. Okay, I guess I'm gonna have to do that device because my let's just start the Windows subsystem for Linux while I wait. No, let's not do that. Let's keep control. So come on up. Android's doing a build. I think I was modifying some files. So we now have support in a mobile app, right? So if we look at this app, it supports Android, iOS, and Mac Catalyst. We're using MAUI, we're using the Cool Single project. And the Cool Single project stuff is that all the stuff that would have been in your separate projects are now in the platform folder. So in the case of Android, let's hop over to VS Code because I've zoomed in. The platforms folder. So in Android, you would have your native Android resources, for example. You would have your manifests. Here's your native Android application using the Android namespaces. Same with like Mac Catalyst and Windows. Here's the XAML for Microsoft WinUI. We've got this Microsoft UI and app model and hosting and all the WinUI stuff. And of course, the same with Mac Catalyst and iOS, right? We've got the app delegates. We've got to register our stuff. We're using Foundation and all that sort of cool things. Here's UIKit. So instead of having separate projects, you would have one project that just has it all in. And I think the toys have come out the cot. No, it's deploying to the emulator. And so this is really cool. And if we look over here, I'll show you another cool thing. Here we got a Blazor and a XAML page. I'll show you some hot reload stuff in a second, as well as we've got this weather page that also has this weather one that's in the mobile app. And it's like, okay, what does this mean? So it means many great things. So let's just say we're launching the app and it's like, oh no, the pop-up. Now this is a native permissions dialog that the native that I wrote the service here. So this, when you do a get location, it's hitting the native API. It's saying, oops, I need to ask for permission. I go ahead and say, okay, hit my permission. And my brilliant UI that I whipped up overnight is doing some GPS location, finding out where I live, and it says, okay, it's going to be cool today. And that's great, right? We're doing XAML, we're doing binding. Let's show you it's really real. Let's head over to the XAML page, and let's just say, hey, this is really a XAML page. Look at that, yay. You're like, you know what? I don't like this wording. I'm just going to do current, and I'm going to do weather. There we go. That's great. You know what? Let's give this text color. Let's make it green because we're cool that way. Look at that stuff. What else can we do? You know what? Let's change some stuff over here. Let's make this pink or hot pink. Let's do hot pink. There we go. Oh, that's nice. I see my layouts a bit dodgy there. So, let's not spend too much time, but let's just say, hey, let's type in the Blazor. There we go. We change some text. So basically, we can even do some crazy things. Let's go ahead and say, you know what? I want to move this to the bottom. Go ahead, just cut and paste, and I said, okay, let's try this out. Grid dot row, and let's make this 1. Okay, and we're going to make this row 0. And of course, let's put a star over here. Trick is to work faster than hot reload. And there we go. So we've gone and we moved our list from the bottom to the top. And of course, we still got this. And, it's all hot reloading. But let's show you something crazy. So yes, you got the mobile app. But what happens if you don't have a mobile app, but you've got a Blazor app? So we can go over to our special Blazor page. That in this case, I have to show a button there so we can get back. But let's assume that this particular Blazor web view filled the entire screen. And here we go. We've got a native Blazor app, or as native as a Blazor app can be when it's running in the web browser. And this is using all the latest browser technology. It's no longer like Android web views. It's using the Chrome views. And of course, on Windows, it's using WebView 2. So it's all high performance. And this very same runtime. In fact, I'll show you. So if I go to my Android service and I stick a breakpoint over here, and then I go to the weather app, right? So this is the web service that's using Android services. And I click weather. So I'm going to download the weather, and my breakpoint should hit over there, along with all my data and thing, and I can go, okay, let's continue that, and I'm getting my location, and here it is. It's the same location, and I'm using the same services that I would have to do some cool stuff. So that is pretty cool. And of course, we got Windows and Mac, so let's hop over to Windows, and let's say, you know what, let's quickly run this boy. And while that launches, let me start up my iOS device, just so we can just show some really cool things with hot restart. But yeah, that's like a really quick overview of some of the cool things. Is sharing Blazor with mobile, and one of the nice things that I particularly enjoy once I got used to it. There's my text upside down at the bottom. And I can go ahead and let's just search for, I don't know, let's save that for iOS. So there we go. We've got our freshly designed. Of course, we can click the Blazor one. And one of the benefits of having Blazor running in an app is like, hey, wait a minute. This detects it's a widescreen, and I can go ahead and have the full-on view. So you can technically have an entire app that's Blazor, and then maybe when you click a link or go to a page, and that is when you switch to a native button, for example. So it's really cool to mix and match your technology. It's no longer, I'm doing a Blazor app, I have to do HTML. It's like, well, you're doing an app. What does this page require? So it's really, really exciting to see technology just all merging into one. So one last thing. Let's switch over to iOS, and things are getting better. And let me think. There's a little bit of an issue that I'm going to pretend it doesn't happen. So if everyone looks away for a second, when you switch away from Windows, Windows doesn't like it. It tries to maintain control of your deployments. So let's switch over to Lonely Screen. I probably should be using real technology and maybe pay this guy for the work, but I'll pretend that I just clicked maybe late on my second screen. But anyway, so while that's launching from a Windows machine, I don't have a Mac. Well, I do have a Mac, but it's off right now. That recipe file is lying to me, and I'm not happy. So switch to that. Let's just switch to iOS again. Let's give it one more go. That was that issue I was saying. I think it's been fixed in preview 11. Well, a preview of VS. So yeah, there was a little exciting little thing where Windows didn't want to. Oh my gosh. You wouldn't believe how many times I practiced this, because the iOS one's a little bit sketchy sometimes. Okay, I'm very sad. One more time. Let's switch to Android. Let's deploy the Android. And while we wait, I can maybe cheat and pretend. Whoops, let's pretend I ran it. And like here it is, the same app running. I pre-deployed it, and Android's deploying. Let's make sure I switch to that. And when the iOS app launches, the debugger will also attach to the iOS app. Right now it's not. And I can go ahead and type in, let's say, Jakarta. And let's see what the weather was. Okay, it's hot in Jakarta right now. It's in the middle of the night, but it's still 33 degrees tomorrow and 30 now. So it's going to be very exciting to be there. But yeah, let me try one more time for the debugger. Come on. All I want to do is show the debugger. Don't fail me now. I practiced a lot. I knew this was going to happen, and I was like, we'll probably close that. And this also can go to Blazor. So right now I have a bad thing with my styles, but here it is. And if I click on the invisible text box, again, running on iOS, we have that same grid that is poorly styled, but we can do all sorts of navigation as it is. So it's all sharing the same services. There's only one version of the GPS service, both the Android, the native app, as well as the Blazor app running in the mobile app is using the exact same instance. We can share, a field on a class because it's shared like that. So hot reload has failed me. I have no idea what this means. Come on. But anyway, let's pretend that never happened and I never did that. But yeah, so that's as much as I can show now before I take up all of Allan's time. But yeah, so it's really, really cool, and everything is shared. And in reality, if you are making an app, you might only have a single project that is targeting, Android, iOS, Mac, Catalyst, and Windows. So I thought all this was really cool. I've been waiting for this to happen for many years, and finally we have reached that thing. All right, so hand back to Allan. Let's see what's happening on IoT. I don't know if Allan's talking.
No. Yeah. So yeah, that was awesome. It's just something for everyone to remember as well. That is preview, so it can fail. And so that was part of your demo. It's by design, right?
Yes, showing the development cycle.
Awesome. Okay, so now we're going to switch over to .NET for IoT devices. So what's really cool about .NET 6 nowadays, and after .NET Core and things like that, .NET can now pretty much run on all different platforms. So .NET 6 for IoT really relies on the ability to run on ARM. You can run on ARM v7 Plus with .NET 6. So that's basically Raspberry Pi 3s if you're into Raspberry Pis and above. It'll even run on the Pi 02, not the Pi 01, because that's ARM v6. So it's cool that .NET runs on an IoT device, but it wouldn't be useful unless you could use the hardware on those devices. So what's also built into .NET and libraries you get for .NET as well is the ability to get to the electronics on these devices as well. So in the past, there wasn't really electronics to speak to in the .NET world, but what's been added now to .NET over the years is the ability to get to things like GPIO, or general purpose inouts, which basically is little pins on your device where you can like set them high or low, or 1 or 0 and things, and you can make things happen. So the namespace system device.gpio gives you the gateway to electronics on the device. There's also IoT.device.bindings, which wraps system.device.gpio and gives you device bindings. So in other words, you can get also higher level groupings of these things. So you can make components, like if you've got a temperature sensor, like a BMP 180 or 280 or something like that, the electronics will be wrapped within device bindings. That allows you to get to things like GPIO or UI for communications, SPI or I2C buses, and all those cool things that you would need in the IoT world. If you want to get started with the apps in IoT, there's .net.microsoft.com. There's some getting started there at apps/IoT. But what we're going to do now is we're going to do a little quick demo to see how .NET 6 runs on a Raspberry Pi. So let me switch over and then start looking at some code. Okay, so hopefully my Visual Studio Code is appearing. I'm going to use Visual Studio Code in this case. I could have used Notepad if I wanted to. I could have used Visual Studio. I'm going to use Visual Studio Code because I can. So what you're seeing here is, and hopefully everyone can see the screen. Please shout if you can't. What we're seeing here is a C# project file. So this project is called MAUI-bot. I'll show you why in a little bit of time. But what I'm showing you here is the project file, and what we are doing here is we're taking it and we are targeting .NET 6, which just that I can show you that it's definitely going to be .NET 6 running on the Raspberry Pi. And here we see we've got the NuGet packages. We're using system.device.gpio, and we're using those IoT device bindings. And we've got some other components that we're bringing in. This is to show little flashy lights and things like that. So this is just the project file. Okay, so what I'm going to do now is I'm going to just switch to this view, and hopefully everyone can see the camera appearing. Matthew, if you can't, just let me know. So what I'm going to do here is just run a little bit of demos using this little robot that's here. It's got a Raspberry Pi 4 in it. It's an AlphaBot 2 for those that's interested in what it is. It's called MAUI Bot because it's built for a MAUI app, which I won't be showing you today. I'll save that for another day. But this is quite a nice platform to give you some just indications on how .NET 6 can work on these type of electronic devices and Raspberry Pis and things like that. Right, so what I'm going to do is just jump into some code here. This is a normal program file. We've got a static void main. If I had to just go do some code here, seeing that's got some, let me show you that you can actually see it. Seeing that if you saw there, it's got wheels, so it's obviously got a motor. So if I had to do something like this, a new motor control, and I had to say, well, motor dot, what you normally have with wheels is you can go direction. So we've got methods here to go forward, left, right, stop. So let's go forward. Let's use our favorite thread.sleep because we like using that. So I'm going to make it sleep for 5 seconds. And then I'm going to say, well, motor, stop, so that it doesn't run forever. So what we're going to have there is a motor that's going to be switched on. We're going to run it for 5 seconds and we're going to stop. If I had to go to just show you the implementation behind that, if you look here, we've got our system.devices.gpio. We've got also system.device.pwm. So PWM is pulse width modulation. And of course, we've got the device drivers for that as well. So PWM is basically you set the duty cycle of a square wave, and the higher the duty cycle is basically the faster it goes. So it actually infers, like, you can then infer speed on a motor. And this little device has 2 motors. So if, of course, on each wheel, so if you make the one wheel faster than the other one, you can then make it go in different directions. But if they go at the same speed in the same direction, of course, it'll go forward. So if we go to the code that says forward, all we're doing is we're setting up duty cycle, setting up speed, and we're just writing to these pins, and these two together will be both motors going forward. Right, so if I had to just run this code, so we're going to a normal run, and what I'm doing here as well is I'm doing a compilation. This IDE that you see here is running on Windows. So I'm doing the development on a Windows machine. It's going to also do a cross-compile to an ARM binary and then deploy it to the Raspberry Pi. And if we see the little wheel running, let me just stop it and run it again. I'm not sure if you caught the little wheel running. So what's happening is it's doing a deploy remotely to the device. It's also running the Visual Studio debugger remotely as well, so I can hit breakpoints and things like that on the device too. So it's running. Hopefully it's clear that wheel is spinning. I can see it. I'm not sure how it translates to YouTube video. And we've got some action happening there on the little bot. Right. So what I'm going to do next is just show you some other features within the libraries that you get for IoT. So I'm going to say, well, let's make a collision this little robot has some little detectors, little infrared detectors that can detect if you hit something or not. So in other words, it'll detect if you like ride into a wall or something like that. So I'm going to make a class called collision detector, and I'm going to say, well, collision collision, because we've got a left and a right. So if I had to do something like this and say collision, I'm just going to generate a method for that. Generate it. Yeah, I'm lazy, so I'm just going to make it. So what I've done here is I've just basically made an event that's linked to this method over here. So what happens is if I had to go just go and have a look at this collision code, what I have here is the ability as well to say, well, you've got this class called the GPIO controller. What you can do as well is you can say, well, these different pins, I can assign events to it, and this is also built into the .NET libraries and stuff for these devices, that you can say, well, I want to register a change in a pin value. So these GPIO pins can have like a 1 or a 0, in other words, on or off. So it's like high voltage or no voltage or low voltage. And you can set events to those things, which is really cool. So you can say, well, if the pin is like falling or going down, then pull some code. If it's going, or it's, you can also say if it's rising, in other words, going up, you can also run some code. So this will also then give you the ability to say, well, I don't have to keep polling pins to find out what's happening. I can say, well, framework, you tell me when it's changed, and then call my code, which is pretty cool. This is something for those that work with these things. Quite a pain to do in like a Arduino and C. So if I had to just say something like, just write it to the C.
Allan, we've lost your audio for a bit there.
Oh,
there you are.
Can you hear me now?
Yeah, we can. So.
So let me just close that. Cool. Hopefully everyone can still hear me. But if I go quiet, please do shout. Okay, so I've got this thing running here. So if I to move near it, I should see, okay, there we go. We should have it detecting, and if I switch off the camera or switch to a smaller camera, we should see there, okay, I've hit the little sensor like 19 times, 20 times. So what's happening here is you can then easily assign events based on what the framework's giving you back from an electronics point of view, which is really, really cool. Okay. Okay, well, let's just do something that's like a little bit funky. So let me get rid of this code. But this other thing called rainbow LEDs, that's got these little LED arrays on it. So I'm going to just run this, and let's say rainbow dot run, and it's how many color cycles we're going to run. So let's run 100. Let's just put it in a loop so we can see it. In this demo code, let's make it sleep for a second. Let's run this. So what we should have, and hopefully everyone can see the little camera in the corner still. It's deploying. And there we go, little flashy lights. So that's like a LED array that's flashing. So the way that works is just going to that code. If I had to go to the rainbow LED class, what it's doing is it's using this RPI WS 28281X package and namespace as well. And what that is actually a C++ library that we've got a binding to. So you can also call into native code and C++ libraries as well. So this is an SO file that's sitting on the Raspberry Pi, and we can bind to that directly. So it also gives you the ability to run really native things as well, not just your managed implementations. And then we get some pretty flashy lights and things like that. Right. So let's go back to our slides. Right, so that was a Raspberry Pi. Now, Raspberry Pi is more like a computer. So it's got a big CPU. So those ARM CPUs are quite big CPUs, and it's got lots of RAM. Like a Raspberry Pi 3, the minimum RAM is like a gig RAM, and you get a 4 gig and an 8 gig version and things like that. That's a substantial machine. So it's a computer with access to electronics. So you wouldn't want to put those type of devices, like if you've got a use case that you need to sit, do some sort of monitoring of systems in the Karoo in a little hut. You don't want to have something that requires a lot of power. So Raspberry Pi is a lowish power device, but it still needs some significant power to make it work. So you do need, if you want to do low power IoT, you do need a better solution than a Raspberry Pi. So that's where MCUs come into it. So MCUs is little single purpose low power little processors. So another option to use is something called the .NET Nano framework. So the Nano framework is a reduced version of .NET and a reduced version of the common runtime. So it's a subset of the .NET base classes, the BCL. And if you see the system requirements for it, it's for really resource constrained devices, and that runs as low as 64K of RAM. So 64K of RAM was a lot of RAM back in the 80s, but it's really nothing nowadays for devices and things like that. So this is a really powerful solution for small devices that you maybe want to run on a watch battery for months and not have to go out to a remote site and change these batteries all the time. So because it's, of course, such a low requirement to run, it, of course, would have to be a subset of .NET. But what's nice about what they've done is they've given basically an API footprint that is a match to .NET. Of course, there's stuff missing. Things like generics is not there yet, and it's coming. Things like async await is not there. and things like that. So you do have to make a little bit of compromise, but I think it's a compromise really worthwhile if you want to run in 64K and for these power requirements. It runs on the metal of the device, so it's really, really efficient. There isn't like an operating system on these things, so it runs actually straight on the device. But you also have the benefits of things like garbage collection and all those type of things. It gives you access to all those things that we were looking at on the Raspberry Pi, like GPIO, UARTs, SPI, I2Cs, and things like that. And it supports a wide range of devices as well. So there's ESP32s, it supports STM chips, Texas Instruments boards, NXPs, Arduino boards. That list is basically what's like support straight. There's also community contributions as well. And different board types as well. So you can run it on a wide range of boards, and you'll be surprised how many variations of these boards there are and where you can run it. So the way that it works, you've got .NET that sits on top, and you've got things called platform abstraction layers and hardware abstraction layers that then they've built it in a modular way that you can then abstract different pieces away from your .NET implementation, so you can then plug in different types of devices via platform abstraction and of course hardware abstraction as well. So it's actually quite nice and modular in design and things like that. If you want to try it out, there's a docs.nanoframework.net where you can go and have a look. Just something to note as well, it's actually an open source project totally. It's community driven. It's also part of the .NET Foundation as well. It's easily flashable as well. So in other words, flash is when you copy your firmware to the device, and of course your firmware and your app to the device as well. So what they've done is, well, they've built .NET global tools called Nanof. You can use that to flash either the base firmware that supports your Nano framework and your .NET runtime, or of course you can then flash it with your app as well. And the way that works is you just basically tell it to you're going to flash, and then you say the target. The target is basically the board support packages or BSPs, and then basically the COM port. So all these things are accessible via a COM port. So when you plug it in, Windows will automatically say, well, whatever port it's on. So of course you can flash it to a port. The Nano firmware flasher, if you go to this URL, you can get some information on that. The tooling for Nano framework is supported by Visual Studio 2019 and 2022. So you also get the full dev experience that you expect within Visual Studio. So you can set breakpoints, you can hit watches, you can do pretty much what you expect to have happen within those environments as well. There's extension that you install into Visual Studio, the .NET Nano Framework extension. It also adds things like the Device Explorer, where you can see what devices are plugged into the machine, and of course that's your conduit to what you're going to be running on. So pretty much like Matthew was showing that you could run your MAUI app onto a device. This is pretty much the same thing where you say, well, I'm going to target that device, and whatever code I've got in Visual Studio will deploy to that device. And that happens via the Device Explorer. Okay, so let's have a quick look at how that works. Yeah, I'm going to swap over to Visual Studio. So I'm moving over to Visual Studio 2022. And we can have a look at how this all comes together. Right, so this project here, what I'm going to do is, people that have been seeing or being pained with all my tweets and stuff, I build lots of things to do with plants and growing of plants and things. So what I've got here is basically a little setup. That's why it's called the sustainability project. We've got the electronics that's needed to grow plants. So in essence, what you need is something to measure moisture. So this is a capacitive moisture sensor. What it does is it basically measures if your soil is wet or dry and stuff, and it's an analog signal. So of course it goes between a range, and you can calibrate that range as well. But what you can use that for is to work out how moist is your soil, to know, and of course and the reason the original reason why I started playing with all these little sensors and stuff for plants is they die if you don't water them. So of course you need to have some sort of way of watering it. So if you know how wet the soil is, you know when to water, and of course when it gets dry, you can then trigger something to water it. So this little block here is called a relay. A relay is basically something that you can use a signal to switch on a higher current supply. So this is like a pump. I'm not going to, probably to everyone's disappointment, I'm not going to plug this pump in because every time I do it, I flood my desk. So this is a pump. You don't want to power a pump straight off these little devices. So of course you power them from a power supply, and of course you switch that on via the relay. So this is basically a floating pump that pumps at quite a rate and things like that. So this is a project we're going to look at and just look at this nano framework in context of the project. Now, this device here that I've got is a ESP32. It's a 32D. So this is generally what they look like. This is actually a very big one because it's got also the dev kit. So of course it's got everything to program it as well. You get them very small. It's like tiny ones. That's probably the size of an SD card and things. But you get them in all shapes and sizes. What I'm going to run it on is what's known as an M5 stack. M5 stack is also an ESP32, but they look like this. What's really cool about this device is it's all integrated in ESP32 in there. It's got a screen. It's got facilities for SD cards. It's also got all the GPIO pins and stuff. This is an M5 stack Core 2. So of course, I'm not sure how clear that's going to be, but it basically gives you all the pinouts and things like that of these GPIO and the I2C buses and where the voltages are and things like that. So what I'm going to do is I'm going to deploy it to M5 stack. It's supported as well by the Nano framework, which is quite nice. I like it because it's got a nice display and stuff, and it's also nice to have it connected to your environment. It also has nice things like Bluetooth, and it's got Wi-Fi out of the box and things like that. It also is nice and modular. You can like plug things in. You can turn it into a gamepad if you want to. You can turn it into a calculator if you want to as well. And this device here that my camera is awkwardly looking at is the one that we're going to be deploying to. You can see it's plugged in there, that we've got all these pieces of electronics and stuff connected to it. Hope everyone could see what I was showing there. I wasn't rambling to myself and everyone could still hear me. I'm known to be doing monologues. Right. Okay, so this is Visual Studio 2022. The device explorer we see here, it's picked up an M5 stack. It's plugged into COM5. So whatever selected here, if I press play, it's going to run it on that device that's displayed there. Similar experience to what happened with deploying to web browsers or deploying to your Android device and things like that as well. Cool. Right. So what I'm going to do now is looking at this device that we've got here. It's got 3 buttons on it. So I'm going to just set up a button quickly. And let's click on it. So to electronics, a button is basically also a GPIO pin, and that GPIO pin you can like click on it or not. So if I had to go over here, I've got the M5 stack class, which is the device I'm working on. I can say, well, I want to say button left. I want to say press. So press, it's basically like a click event. And I'm going to add what happens when I click on it. So like we were showing on the Raspberry Pi, like I was showing on the Raspberry Pi, you can then like assign different events to things. So I've created this method down here, which is press. Just as an example, I've got this relay. Relay. Let's just switch the relay on if I click on a button. So let's make this. This will be easier. Let's just say relay. Oh, it's toggle. So we're just going to switch it on and off if I press on the button. Cool. So hopefully everyone can still follow what I'm doing. Right. So now I'm going to press play. Let's see what happens. Yeah, so you'll see what's happening. It's pulling in all the libraries that's needed. You'll probably recognize all those names and things. It's very close to what we had for the Raspberry Pi, and now it's deploying to the device. As I was saying before, when you deploy, you've also got the full debug capabilities, breakpoints, and all those type of things as well. So, okay, cool. Let me make that bigger. So if I had to press on the left button, it's still starting up. I'm in too much of a hurry. This is when you're trying to be faster than hot reload, eh, Matthew? So you'll see a little light comes on. So that's the relay switching on and off. So what we've done is we basically had a GPIO trigger, and now we're switching on a relay. And if we had to go look at the code for the relay, it's actually very, very simple. Let's go to the Solution Explorer. And while I'm here, it's just this Nano framework is just another .NET project. You've got your C# files. We've got a program.cs. We've got resources if you want to put resources.
Yeah, Allan, you must just hide the camera. You're blocking it all with the gadgets.
Apologies. Okay, cool. So hopefully you can see it now. So it's just a normal .NET project. You've got your C# files in wherever you want to put them and things like that. So I was going to go show you where this relay code is. So let me go to the toggle relay. All it is basically saying, well, set relay pin high or pin low. So it's in other words on and off. And all that is saying, well, this is a GPIO pin. And all we're going to do is write to the pin. So we're either writing a 1 or a 0 to it. And that's how you control GPIO pins. Something out of interest, if you look at the top here, again, like we were having with the Raspberry Pi, we've got system.is.gpio. And you've got the same concepts and ideas happening behind that, which you've got use that to control your GPIO and your I2Cs and all those type of things. So there we've got a simple implementation of just switching a relay on and off. I could go, well, I've got this moisture sensor. I could say, well, moisture sensor dot, there's a get percentage, equals. That's, I could say now this M5 stack's luckily got a screen, so I could say, well, let's write to the console, which is its screen. So I could say, well, write line, and I could say, well, let's write that reading to it. Maybe we could say, well, let's say console dot top of the cursor. Let's put that 0. In other words, the position on the screen. We could say, well, let's make it look pretty. And we could say, well, this is just something like that, right? So what we're doing is we connecting to our moisture sensor, which is this DF robot moisture sensor. Go to that. So all this is reading from a ADC controller. It's an analog to digital converter controller. And what we're looking at is, instead of a on-off, we're looking at an analog value, which is a scale between, of course, 0 and the maximum value that you can read from that port. It's basically a voltage that's being returned. So we get percentage. We're reading from the sensor, and the important part here is we can just ask the analog to digital channel for the reading, and of course we're just reading the value in, and the rest of the code is just saying, well, with this moisture reader, we want to calibrate it to know what the percentage is. So what we do is we just put it in, we calibrate the sensor normally by saying, well, when the sensor is in the air, we're getting that reading, and if it's in the water, we're getting that reading, and somewhere in between is your moisture value. So of course, in the middle would be 50%. If you like towards the higher value, of course, the percentage will drop down. So we just got a little calculation that works that out. Okay, so let's run this and see if it works. You're going to be able to see the screen. Let's have a look. Is there any questions? I'm going to assume silence means no, or my mic's not working.
There doesn't seem to be any questions.
Okay, no, cool. All right, it's deployed. Let's see, the program. Okay, so it's running. Text on the screen. Not very clear for you, but we've got our reading that's happening there. So output to the screen, of course, we're reading from our device and things like that. And there we go. Now, oops, you can also then take it slightly further. I've got in my house, there's a whole home automation system running that controls lights and aircon units and different pumps and things like that. That's all on the property. So what I'm going to do is just fire up, as an example, this little environment monitor. Let's say, well, this is 7. What it's going to do is send some telemetry to a MQTT server that's running also on a Raspberry Pi. So seeing that these ESP32s are Wi-Fi enabled, I'm just going to wait. Let me just do this quickly and uncomment that. So what we've got here is an MQTT client, which is message queue telemetry transport client. What's MQTT is great for sending things like temperature readings, humidity readings, and things like that. It also works kind of like a message bus, so you can like, put these messages and things on a bus. So what's going to happen here is, and these are just libraries out of the box. You can get the MQTT client. Here we're subscribing to topics on the MQTT bus. The Sonoff aircon is basically reading the power usage of an aircon, and this environment monitor is that monitor that I switched on, which is this one. Okay, so what did I do here? Oops. Got that. Okay, cool. So what I've got here is an event that says, well, when a message is received, call this code over here. So it's an event that gets fired. So if a message that we subscribe to arrives, let's call some code. So I think I broke something here. What did I do? Oh, right. So when the message arrives, I'm going to check the topic, and then I'm going to do some voodoo on it, and I'm going to get the message, which is now coming from an environment monitor, which is another Raspberry Pi in another room. I'm going to take that message, and if you notice here, there's JSON converts. So for those that use Newtonsoft, this is very similar. It doesn't come from Newtonsoft. They have an API equivalent. So that comes from nanoframework.json. So what you'll learn about Nano Framework is if you go to NuGet and you search for Nano Framework and something, you will find a library that's equivalent to APIs that you already know. Just something to note, you'll notice that this is using deserialize. There isn't a generic form of it, so those used for Newtonsoft, it's the non-generic version. So of course there we've got a cast that's happening here because it returns an object. That's apparently coming in a later version of Nano Framework, but it's not quite there now. So what's going to happen when that message comes? We're going to get some environmental data, and we're going to display it on the screen as well. So let's run that. See if I can get the screen clearer. It's going to be on position 4 on the screen as well. Okay. That's pulling out the wires. Going to receive a message. See if this is all running. Okay, it's publishing. Okay, so there we go. Let me just make that smaller so you can see. So what we've got is a message that's came through by MQTT, and we should have pushed it to the screen as well. So it's not, contrast is not great, but there's the temperature appearing. So it's very easy to like use these devices with Nano Framework on a network. You can just hook things up. Just another quick example, I can say, well, if I press the right button, what I'm going to do is switch on the lights that's in the office. So let's just switch that on. This is just going to publish to a topic. It's going to say switch it on. Okay, let's wait for it to deploy. Deploying. Didn't see that code. It's basically we're going to publish to a topic, and we're going to say switch it on. on the right button click. There we go. Wow. Bright lights. Yeah. So it's really, really simple with .NET Nano framework to make these MCUs work. Significantly more complicated if you're using C++ and using their native implementation environments. Cool. Hope everyone's still awake and with me and can still hear me.
Yeah,
Okay.
I'm still here.
Oh yeah. Are you still there?
With lots of
Awesome. Okay, and then there's another option. There's a company called Wilderness Labs. They make what's known as a Meadow. So Meadow's actually a board. They actually the hardware manufacturer. It's a F7 chip. What's nice about this Wilderness Labs is it conforms, and if you think back to what I said about Nano framework, is it's a subset of .NET. So you can't take it and put it into like a .NET standard library and share the code with something like a Xamarin, MAUI, or Blazor and things like that, because it's a subset. So of course that code can't really be shared. It can look the same, and there's different techniques of sharing code that look the same, but you can't just put it in assembly and then share it. So the power of the Wilderness Labs Meadow is it runs full .NET. It's running .NET Standard 2.1, so in other words, .NET 5 equivalent API footprint. They are working to make a .NET 6 one. But if you do want to do some sort of IoT that's MCU related, and it's like fills the middle ground between the really low power devices and of course things like Raspberry Pis and things, these work quite nicely. But you are constrained to these devices from this company as well. And the specs of them, you've got 32 meg of RAM. It also gives support for GPIO, UARTs, and SPIs and I2Cs, and it's got all nice things like BLE, Wi-Fi, Ethernet, and stuff like that. These devices, you can actually take them live. They are intended to be prototyping devices and things you can take live as well. So if you're interested in having a look at that, this wildernesslabs.co is the place to go and have a look. Right, so all the stuff that Matthew and myself showed, you can get started with it today. You can download .NET 6. There's the links and stuff for Visual Studio 2022, links to the upgrade assistant. You can go try all that cool stuff that Matthew showed in MAUI preview. You just remember you need Visual Studio 2022 preview to try out MAUI. And if you want to play around with the Nano framework, there's a nice getting started guide on the Nano framework site. Okay, is there any questions? Any observations? Anything? If there's not,
I've got a question, Allan.
Oh yes.
What's the sort of overhead from using the Nano framework as opposed to like hardcore C++?
It actually compiles down to very, very close to C++. As I say, it like runs on the metal. It's okay. Basically really as close as you get. It's actually very, very efficient.
Okay, wow, very cool.
Yeah, because it's not quite like the Wilderness Labs will run on the Mono framework, which is not quite on the metal type thing. Although you can compile it natively down. But yeah, the Nano framework is actually very, very efficient.
Nice.
Yeah, and if you look at the specs and stuff, if it works in like a 64K 64K device, it's really minimal that it puts down.
Yeah, yeah.
Is there any other questions?
I
Do you
don't
have more?
see any others. No, I don't know any more. I don't see any others in the chat.
Okay, no, cool.
What is the TFM actually, or the target framework for the Nano framework and the Meta one? Right, obviously the Meta is net standard, but what is the Nano framework? Like, is this
The
net
Meta,
5? Or?
the Metas is standard 2.1. But the Nano framework is a totally different framework. Okay, it's not as part of that family of things. So its history, it comes from the micro framework or the compact framework, and the micro framework, and it evolved into the Nano framework. So it doesn't quite fit into that mold. It's a totally separate implementation, but matches the API footprint.
Okay.
That answers the question.
So Louise wants to know, where do we buy the moisture things? And also, I suppose that's, well, let's say you were a hobbyist starting up, you found this random electronic gadget.
Yeah, all those components that I showed, you can buy at Micro Robotics. They're based in, I think, Centurion and Stellenbosch. You could also get them at the Pi Shop as well, pieshop.co.za.
So Louise, are you planning some electronics now?
Yeah, that sounds.
Are we expecting some stuff?
She's going to build her own Terminator with a moisture sensor.
I need moisture.
Yes. Yeah, if there's no questions, thank you everyone for attending. I know it's late in the year as well to attend these things, so thank you very much for attending. If you have something you want to present, we have 2 session-eyes as well for Cape Town and Johannesburg. Everyone's got something interesting to say, so if you want to submit your talks, please do submit to session-eyes. We'd love to have you present at the user groups as well. Cool. Yeah, if there's nothing more, have a good evening and see you December the 8th, hopefully.
Yeah. Cheerio, folks.
Cool.
Ciao. Oops.
That's 2 weeks.